All right, hi everybody. Today we're gonna go over notes. So hopefully this layout doesn't look too weird. We're gonna kind of I'll draw it out as we go, as what order we should be in, and then I will also show my work as we're working through these problems. So today we're gonna focus on Boyle and Charles' law. There are two equations on here that you can already see that you are going to need to write on your periodic table. Highly recommend writing those down if you don't already, or if you haven't already, just write them down so you have them. Okay, so the first thing we're going to start with is our first slide right here, talking about Boyle's law of pressure and volume. So Robert Boyle was the first person to study the pressure versus volume relationship. So in 1662, Boyle proposed a law to describe this relationship. So like we talked about yesterday, we talked about that when the volume increases, we should see a decrease in pressure, and then as we see a decrease in volume, we should see an increase in pressure. So he came up with his law, which is for a given mass of a gas at constant temperature, the volume of a gas varies inversely with the pressure. So he came up with his equation for Boyle's law, which is P1 times V1 equals P2 times V2. P1 and V1 are both pressures, and they need to be in whatever unit, but they have to match. So they either both have to be in ATM, kPa, or millimeters of mercury. Our volume has to be in either liters or milliliters, but again, they have to match. If they don't, we need to convert them to make them match. So if we go into our first problem here, so a gas has a volume of 30.0 liters at 150 kPa. What is the volume of a gas at 0.252 atm? So the first thing I like to do when I solve these problems is list out my variables for Boyle's law, which is P1, V1, P2, V2, just so I know what I'm missing and what I have. So I look at my problem. The first pressure I see is 150 kPa. So 150 kPa. My first volume that I run into is 30.0 liters. Okay? And it asks, what is the volume of a gas at 0.252 atm? So that means if it's an atm, that is a pressure. So equals 0.252 atm. And that's telling me I do not know what my volume is. So now that I have these, I'm going to compare my pressures to each other to make sure they're in the same unit and my volume and figure out what my final unit will be. So I'm in kPa and atm. That means I need to convert one to match the other. It's up to you on what you would like to match it with. It should work out the same in the end anyway. But I'm going to convert kPa into atm. I think that's just a little bit easier to write out. Again, those conversion factors are either on the board or they are in your notes. So make sure you get those written down somewhere on your periodic table. So if I have kPa for 1 atm, so I have 1 atm on top, and that goes to every 101.3 kPa. Okay, so I'm going to take 150 times 1 divided by 101.3. You should get an answer of 1.5 atm. Okay, so now I have 1.5 atm for my pressure 1. Pressure 2 is at 0.252. I forgot a number there. Make some room. And my volume's in liters. That means my final answer needs to be in liters. So if you want to leave yourself a little note, you absolutely can. Okay, so our equation, P1 times V1 equals P2 times V2. So I'm going to start with my P1, which is 1.5, times my volume 1, which we said was 30.0, equals my 0.252 atm times my volume, which is V2. You can always write V2 as X if you think that's a little bit easier for you. Just make sure that you know that's going to be your volume 2 when you solve. Okay, so this is just a normal algebraic equation, and so we need to rearrange it so that our volume here is all on its own. So what I'm going to do first, I'm going to multiply my 1.5 to 30 just to get that out of the way. So 1.5 times 30 is 45. So 45 equals 0.252 times my volume 2. And again, you can write that as X. So I want to get that volume 2 on its own, so I'm going to divide my 0.252 on both sides. So 45 divided by 0.252 equals 178.571, and there's more to that, but we're going to put it in sig figs so we don't have to worry about it. I look up at my problem, 30.0 is 3 sig figs, this is 2 sig figs, 3 sig figs. I always go to the lowest amount, so I'm going to go to 2 sig figs. So I have 1, 2, look behind, it's an 8. So I'm going to round that up to an 8. So it's going to be 18, but we know 18 and 178 are not the same thing, so we're going to add a placeholding 0 behind it. And I know this is going to be my volume. I already said my volume needs to be in liters. So my final unit should be liters. So my final answer should be 180 liters will be my volume 2. Okay, so that is Boyle's law. Now we're going to get into Charles' law. So Charles came in, he studied the effects of temperature on volume of a gas at a constant pressure. So for this time, the pressure is not changing, it's just the volume, the size of the container that we're dealing with. So he came up with this law, says for a given mass of a the given mass of a gas at constant pressure, the volume of a gas is directly proportional to its temperature. So he came up with this equation. V1 divided by T1 equals V2 divided by T2. So V1 and V2 are your volumes. Again, both are in liters or milliliters, and they have to match. Our temperatures are T1 and T2, and they need to both be in Kelvin. And that's your only option. So if you're given everything in Celsius, you have to convert to Kelvin, and I will show you how to do that. So here is our problem. So a gas has a volume of 4.0 liters at 27 degrees Celsius. What is the volume at 153 degrees Celsius? So since I know this is Charles' law, I'm going to list all my variables out. So I have V1, T1, V2, T2. So again, just like in Boyle's law, the first volume I run into, which would be my 4.0 liters, is going to be my volume 1. And the first temperature I run into is going to be my T2, so 27 degrees Celsius. What is the volume? So it's telling me I don't know what my volume is. And at a temperature of 153 degrees Celsius. Now, like we just talked about, our temperature has to be in Kelvin. So to convert from Celsius to Kelvin, we're just going to add 273. I know on the slides yesterday it said 273.13 or 15 or something. Don't worry about the decimal. It's not big enough to significantly change your answer. So when I do 27 plus 273, you should get 300 Kelvin. And 153 plus 273, you should get 426 Kelvin. Okay, I'm going to check my volume real quick. So my first volume is in liters. That means my volume 2 will have a final answer in liters. Okay, now I have everything. I only have one variable that's missing. I can plug it in. So my equation again is V1 divided by T1 equals V2 divided by T2. So my V1 is my 4.0 liters divided by my temperature of 300 degrees Kelvin equals my volume 2, which we don't know. Again, you could put that as X if you wanted to. And my temperature 2 will be 426 Kelvin. Now, the easiest way to do this, personally, I think to cross multiply is the easiest between these two. So I'm going to take 4.0 times 426. And you should get 1,704 equals 300 V2. I'm then going to divide by 300 on both sides. And you should get an answer of 5.68. Okay? Now I need to look at my sig figs. 4.0 is 2 sig figs. 27 is 2 sig figs. 153 degrees Celsius is 3 sig figs. We always go to the lowest amount. So I'm going to go to 2 sig figs. I go 1, 2. I look behind. It's an 8. So that means I'm going to round up my final answer to be 5.7. And we said that our final answer needs to be in liters. So that means my final unit will be in liters. Okay, so that is all I have for today. Try your best on the homework. We will go over it on Thursday when I get back. If you have any questions, please let me know. Have a